Welcome, ladies and gentlemen, to a new video about Alusus programming language. In this video, I'm going to talk a little bit more about building web interfaces in Alusus and WebPlatform. We've come across this in prior videos if you have seen it before, but in this video, I'm going to focus a little bit more about what the best practices are. So, as usual, I'm going to do that through an example. And we have this simple example. We have seen this before. It's not the first time. If you have seen the previous video, you already know what I'm talking about. So in Alusus language, if you are going to build a new, a web interface, then you basically depend mostly on this operator in Alusus language, which is the dot, then curly bracket, which is I think it's called the command packs or something like that, which is basically grouping a set of commands within to excuse me, to be applied on a specific object. So in this case, we have this call, which is creating a box, and then we're using this property to apply everything in between on this box, and then in between we're setting styles. Then we're calling the add children method of this box, and then within that we're creating other widgets and so on. So basically this allows you to build a tree of objects, which is what we usually need in user interfaces. Without this allows you to build these user interface trees without having to depend on a YAML file or XML or JSON or whatever. So this is something we've seen before. In this example, we have a very simple example. It's just a single function, which is the main function that defines the interface to be a box. Inside that box, there is another box inside, which again sets style, and then that inside that box there is a text input and a button, and then outside next to that outer box there is a text. So the idea here, let me run the example and see what it looks like. The idea here is to simulate, have a simple interface where you can enter text, click a button, and then have something done on that text. So if we open that, then it will look something like this. So we have, this is the entry box, this is the send button, and this is, we want that text to simply appear here. So we're not going to do any actual sending to anywhere. We're just going to simulate that by having it appear here. So right now it's not mapped, or it's not hooked up, so it's not doing anything. So let's see how to do that. So in here you can see that we have the text input. We're setting a closure on the onKeyUp event, and the goal here is that when the user clicks Shift plus Enter, that we will send that text to that text entry. And then here same thing. There is box. There is and then we have the onClick event handled here. So in order to do that, let's first move this to the top, put it here at the top, and I'll mention later why I want to do this first. But anyway, so this is our tree. As you can see here, we're not defining any variables. There is literally 0 variables defined in this function. So then the question is, how do we reach to these objects to be able to interact with them in our code? So let's look at this text. This is the first thing we need to do. So we need to be able to have a reference to this text widget, so we can change its value here inside these event handlers. And the way to do that is to store this in a variable. So we can simply define a text widget and define that as a shared ref of type text. And in here, we can use the same thing, which is the curly bracket, the command pack operator, and then we say text equals this. Sorry, this. So in this case, we're storing the value of, or like the reference to this object. We're storing it in text. So inside the command pack arguments or the operator, this refers to whatever was before the dot. So this refers to that, the result of this text call, which is basically a reference to that object. So we have this reference, we're simply storing it in this variable. Now, someone might wonder, why do we do this? Why don't we just define this way, and then here we can just say, we can just do this. You can, and it works, but it's not very readable. Now, in this case, it's simple. The text is defined at the beginning. That's fine. But if we also need to capture like references to objects in the middle of a big tree, then it's not going to be readable to have those elements extracted out, especially when you have things nested. So the clearer thing, the more readable way to do it is to have your let me undo this. Is to have your tree represent exactly what's visible, what's going to be visible on the screen, and then capture, like, and within that tree capture the variables you want. That makes your code more readable, and it's easier to write also. Also keep in mind that if you like, let's say you have if you want to do it the traditional way, and you have a widget, and inside that there's another widget, and you want to capture both of them, so you will need to define the inner one first and then the outer one. And so the order in which you define your widgets or your variables will need to be reversed. So you need to create the inner element first, and then the outer element, obviously, because you need to have that reference, because you need to pass it to the outer one. But in this case, when you use the command packs, it's clearer, because you define things top to bottom, from like basically according to how the tree looks like, and the compiler takes care of the instantiating them in the right order in order to pass each element to its parent. So the compiler takes care of that. Everything looks readable. Everything looks according to how you would expect them, in the same order, in the same order that you would expect to see on the browser. So this is the method we recommend. Now going back, I captured the reference to this text object, and now we just need to address that. So that here we can simply say text actually. Let me just rename this to something to label, just so we don't get confused here. So our label has a text property, and we set that text property to widget.text. Let's see if this works. And now we can refresh. So text here, hi, that works. Now we also need to do it here. So we can say label.text equals what? Widget here refers to the button, so we can't use widget as we did here. So what we'll do is we'll capture another variable. Let's define text entry. Is that the name of the text input? And then in the text input, same thing, text input equals this. And here we can say text input dot text. So that should work. Hi, and then click send. It works. So this is overall, this is the way to define user interfaces, but there's a problem here. There's a couple of problems actually, and I'm gonna show these problems and then mention how best to avoid these things, or what's the best practice. So let's say we just move this from here to the end, and let's try again. Refresh. Now this, you can see here, like I moved it to the bottom, and now it looks here at the bottom, just as you would expect. So it looks alright, but now take a look at here. So if we say hi, send, it didn't work. And now if we look at the code here, you can see there's a runtime error. There's a call to null, and the reason for this is because of the order in which things are defined. So the one thing to note here is that closures, the way closures work is that they capture a copy of the data it's using, and in here, and the data is captured at the time the closure is created. So when we reach this point where we define the closure, we're capturing any data, or the compiler is capturing any data the closure needs. In this case, we're depending on label, which is this, and then widget. Widget is an argument, so that's fine, but label is this variable. But at this point, you can see label is actually assigned here. So at this point, we're creating the closure before the label is even assigned. So we're capturing a copy of that label, which is null, and so the closure is packaged with a null value for the label, and so it doesn't work. So in order to overcome this, you need to tell the closure to capture this by reference. So you can say label by ref. This is how you tell the closure how to capture the variables. So by default it captures by value. So now I'm overriding that and telling it don't capture by value, capture by reference. So now instead of getting a copy of label, it takes a reference to it. So when label later on changes, it will work. So label by reference, same thing, and let's run again. That should fix it. Hi. That's fixed. But there is still another problem. Let's assume you want to organize your code a little bit and have a separate function, create interface, which returns a shared reference to box. And then you simply want all of this to be create interface to be created here, and you just say return. So you have this function. So if I run this, I'll get compilation error now, because here I'm trying to access example of line 23. I'm trying to access text input, which is not defined in this function, so I need to define it. It's defined here. So if I move these up here, this will fix the compiler error, but it will still have an issue. Let's see. So as you see, the interface is created. That looks as expected. Now let's try to again send a message, and I got a runtime error, index out of bound. And the reason for this is because label and text input are defined as local variables within create interface. And at least for the case of label, we're capturing a reference to this label. So we're capturing a reference to a variable that will then be removed from memory at the end of the function. And that's exactly what's happening. So in order to fix this, one way is to define it as global variables. That should fix it, but that's as you may already know, that's not the recommended way. Let's see that. Hi, send. It works. So yeah, it works, but again, that's not the recommended way. And let's show a simple example why it's not recommended. Let's do a box here, and then say add children, and then we can simply duplicate this. I think you already know or can expect what will happen. Let's refresh. As expected, we got 2 copies of this interface, so let's try to say something here. Hi, send. Nothing happened, or we got space or empty string instead, so let's say hello here and press send. The second one works as expected, and then let's try this one again, and let's change this to hello2 and click this send. This changed to hello2. So as you see, regardless of which button you click or which enter you click or press in these text boxes, it will always grab a copy of this and place it into the second. That will always just deal with the second group of variables, and obviously that's because the second time you called create interface, you overrode the values of these with the new values from the second call. So you always have just the last variable. So that's why it's not recommended to use global variables, which is not really specific to Alusus language or to doing web development or to this library. It's just a general concept. Global variables should really we should really minimize the dependence of global variables. So this brings us to the main question: how do we then address this? What's the recommended way, the best practice to build user interfaces in the web platform library and Alusus language? And the answer is components, which I guess you might have expected that already, since components are also used in many other frameworks like React, Angular, whatever. I think all of them maybe. So the way to define a component is to simply create your own class, name it whatever. So I'm going to name it interface, and have it inherit from a component, the component class. And the way to do that is by saying injection, and then you define component to be component. So this is the way you do inheritance in Alusus, and this is actually like the basic way to inherit. This is the way inheritance works in the first place. Inheritance is basically containment plus having the contained object exposed in the outer scope. That's really what inheritance is all about. So, and that's exactly what we're doing here. So we're just defining a component of that component, and we're just telling the compiler that member variables of this should be injected into the parent, the outer class. So this just defines a class, and we can address, or we can create the interface in the constructor of this class, and we can say, and this is done by saying handler this init, and inside we can simply take all of this and put it here, and we can just say this.view equals all of this. And let me fix the indentation a little bit. Yeah. So this interface defines all of that, and then we need to make it easier to instantiate objects of this. We can define this operator on the type. We define an operator, we override the parentheses operator on the type itself rather than on the objects of that type, and we tell it that the return value is shared ref interface. So let me write the implementation and then explain what this is. So we tell it return interface construct. So we define a shared reference of type interface, and we call construct, which is a member function of or a method of the shared ref to actually construct the object. Now, what this does is it overrides or this operation, the behavior of this operation. So by default, when you have a class and you use parentheses after the class, the compiler by default creates a stack or a local variable, a temporary variable. And in this case, we're telling it, instead of using the default behavior by creating a variable on the stack, call this function instead. And in this case, we're telling it to construct an object on the heap and have a shared reference to it. So this makes it easier to construct these instances of this interface. Now, the other thing we need to do here is that, well, we don't need this anymore, so let's remove it. The other thing we need to do is we need to move these to make them not global, because that's what we're trying to avoid in the first place. So let's define them as member variables. And now, in order to access these member variables, we need to access them on the object. So we need to do this, but we can't do this here because this, in this case, refers to the text input, just like here. So here, we know, as we mentioned earlier, this refers to this object rather than to the class. So what we need to do is to capture a reference to the class, so we can, with a different name, so we can use it without the conflict. So we can simply say define self to be a reference to this type, and instantiate its value with this. So now we can use self throughout the class, and making sure that it actually refers to the object, to the component itself. So in this case, we say self text input, same thing, self text input, self.label. Do we have other labels? This one, self.label, and we don't need this anymore, and we don't need this anymore, and same thing, self.label. So okay, and text input, self, okay. So the only thing remaining is to replace these with interface. And now let's see if this fixes our issues. Test 1, test 2, it works. So that is that's basically how you define interfaces now. Define components. And of course, the remaining is pretty self-explanatory. Like, let's assume we want to allow the user from outside the component to interact with elements of this component. So, for example, let's say we want the user to be able to set the value of text input. So we can simply say handler. We can define a property. We can say this.text equals a string. And then in this case, we can say this.text input.text equals value, which is the value passed to this operator. So this syntax is basically the way you override or you define properties. So this is basically a set property. It's telling it to override the operator equals when it's called on this member, like when we call, when you have the object, any object interface, and say text equals some string, then this basically tell it, like when you get this syntax, call this instead. So to call this, we set the value, we need to return the value after that, just because an assign operator needs to still return a value, but that's just an implementation detail we don't need to worry about. So now let's give that a try. So let's say here when we define this, let's do the same thing. Let's say text equals value 1. This needs to be a string object, and text equals value 2, and I forgot to, so this should allow us to put some initial values. Reload, and now you can see it starts with the default values. Same thing if we want to receive callbacks from the component. So let's say let's define on text entered. Sure, let's call it that, and it's a closure that takes a string. And now we can say here when we click this, we can say if self dot is null. If not, it is null, then we call it self dot, and we give it widget.text. And let's do the same here. And obviously here, instead of calling widget.text, we start with text input. So now we can, in here we can say on text entered equals closure, and we can say anything. Let's say just log to console and just say value from field 1 plus str, and let's do the same for the other one. Change this into 2, save, let's restart. Okay, so reload, let's just call send value from field 1, send again value from field 2. And that's it. That's how you create components and interact with them. Once you create the component, it becomes just like any other widget. Anything you define, any properties or closures you define on it is exposed outside, and you can just deal with it just like any native widget. Before I end this video, I want to talk a little bit about cleaning up or freeing resources at the end of your interface, or at the exit of your interface. So one difference between Alusus language and JavaScript is that Alusus is not a garbage collected language. It depends on reference counting instead. And the benefits, the main advantage there, obviously there's performance and memory resource consumption benefits here. But the other benefit in addition to these is that reference counting is predictable. So we know exactly when an object will be freed from memory, and we know exactly when the destructor of that object is called. So if we want to clean up resources, we can simply define a destructor. So we can say handler this terminate, and we can say free log to console free resources. I mean, in this case, we don't have any resources to free because these are all reference counted and they'll be freed automatically. But if you have things like a call being in progress, like an HTTP call in progress, or you have a timer that you want to clean up before you exit. All these kind of resource freeing, we can just do them in the destructor. We don't have to do any like special registering special functions or whatever, like you do with React or Angular or whatever. So you just define the destructor. So now let's give that a try. Let's see if we simply say window.instance.setView and say text done. So, I mean, this is going to be a stupid thing because you're creating an interface and deleting it immediately after. But let's see what actually happens. What did I miss? 107. This needs to be a string. Sorry, I forgot to switch my language to English before starting the video, but that's fine. These are all like simple syntax error or like simple compilation errors. So now if we reload, you can see free resources is called twice. So let's explain a little bit what happens behind the scenes. So unlike React or Angular, there is no such thing as a life cycle, and this is mainly driven by the language itself being deterministic because it depends on reference counting, as I mentioned, but also just because of the overall design of the web platform library. So in web platform and Alusus, things are predictable. You know exactly what's happening when something is reflected on the browser, when a change in the browser is reflected on your data. And in the case of web platform, everything happens instantly, immediately. There's no separation between your data and the browser. Whatever you change on your objects or widgets will immediately be reflected on the browser. So, for example, here when we call set view at this function, within this function, before we return from this function, we know these objects are created and are actually reflected on the browser. They're actually rendered and shown to the user before we, I mean, not necessarily shown to the user, but reflected in the DOM. They're already in the DOM before this function is returned. And the same thing happens when we call the set view again. So when we call this, we know before this set view call returns, all of these objects have already been cleaned and removed from memory, and their destructors are already called before this function returns, and like the new objects are created. All of that happens before the function returns. Same thing when we, for example, do something like this: self.label.text equals. At this point, before this call ends, we know that the text on the browser, or on the DOM, not the browser, on the DOM is already updated. So it's all deterministic. There's no buffer between the time you take an action and the time the action is actually reflected in the DOM. And the same thing happens when we call this, when we call self text text input.text. At this point, we're actually fetching the data directly from the DOM. So there's no separating. So all of this means things are very, very predictable. There's no surprises for you as a user, as a programmer, or to your user. There's no surprises. Everything is instantaneous. There's no gap in separation and a life cycle that happens behind the scenes. And this also, in addition to the predictability, which predictability in itself means more stability, but in addition to that, you also get better performance, as we have seen in the previous video. If you have seen that, if you haven't, please watch it. There's a video that compares the performance of Alusus and web platform to React, and you can see the big difference there. So that's basically it. So when if you want to build user interfaces, the approach we recommend is to break your user interface into smaller components, smaller sections, and then implement each section as a reusable component. You can easily nest components within each other. So that's basically the cleanest way. It's also similar to what most most user interface most user interfaces are written as, and most libraries recommends that. So again, just break everything into smaller components, reusable components, and then have your main function simply create that big main view component, or you can call it whatever. And that is basically the way we recommend in terms of how you build user interfaces. And that's it for this video. Stay tuned to our channel, subscribe if you haven't already, and share this video with others who might be interested. And look forward to our upcoming videos. We'll have videos about other things, including routing and styling, among others. So that's it for now. Thanks for watching, and have a good rest of the day.